Welcome back to the AI Academy. Today's session is all about setting up the environment for BERTopic modeling. Let's get started with the necessary installations and configurations. To get started with BERTopic, you'll need to install a few libraries and set up your Python environment. Let's go through the steps together. First, ensure you have Python installed on your machine. It's recommended to use Python 3.7 or later. Next, you'll need to install BERTopic and its dependencies. Open your command line interface, CLI, and run the following command. pip install BERTopic. This command will install BERTopic, along with other necessary libraries like NumPy, Pandas, scikit-learn, and Transformers. Setting up Python environment using Anaconda is a convenient way to manage your Python environment and dependencies. Here's how you can set it up. Step 1. Install Anaconda. If you haven't already, download and install Anaconda from the official website. Step 2. Create a new environment. Open Anaconda prompt and create a new environment. Conda create and BERTopic_env Python equals 3.8. Step 3. Activate the environment. Conda activate BERTopic_env. Step 4. Install Jupyter Notebook. The Jupyter Notebook is a great tool for interactive coding and data analysis. Install it within your environment. With Conda install Jupyter. Step 5. Now, install BERTopic in your Anaconda environment with pip install BERTopic. Launch Jupyter Notebook. Begin working with BERTopic. By following these steps, you'll have a fully set up Python environment ready for BERTopic. Let us now look into the overview of prerequisites. So before diving into BERTopic, it's essential to have some foundational knowledge. Let's go over the basics you'll need. To work effectively with BERTopic, you should be comfortable with Python syntax. You should have understanding variables, loops, conditionals, and functions. And should be familiar with importing and using libraries like NumPy, Pandas, and Matplotlib. You should have basic knowledge about SpaCy. The SpaCy is a robust NLP library for advanced text processing. The main features of SpaCy are tokenization, which is about breaking down text into individual words or tokens. Lemmatization, reducing words to their base or root form, such as running to run. Named entity recognition, NER identifying proper nouns in text, like names of people, organizations, or locations. Let us now look into the NLTK, the Natural Language Toolkit, a comprehensive library for NLP tasks. The features of the NLTK are, text processing, provides various utilities for processing raw text. The tokenization, it breaks down text into individual words or sentences. The stemming, reduces words to their root form, such as running to run. And it is also corpus reader, which allows access and processing of large collections of text, corpora. For example, NLTK can tokenize a sentence like natural language processing with Python is fun. Into individual words such as natural language processing with Python is fun! Let's break down the code example. So first, the import NLTK line imports the NLTK library, which is packed with tools and datasets for natural language processing. NLTK.download of punct command downloads the punct tokenizer models, which are necessary for splitting a text into sentences or words. From NLTK.tokenize import word_tokenize, we import the word_tokenize function from NLTK, which will help us split the text into individual words. The words equals word_tokenize of text function splits the text into words and punctuation marks, returning a list of tokens. NLTK is incredibly versatile and can handle a wide range of text processing tasks, making it a valuable tool for anyone working with natural language data. Let us now look into the Gensim library specialized in topic modeling and document similarity. The key features are the LDA, latent Dirichlet allocation, a technique for discovering topics within a collection of documents, Word2Vec, it computes vector representations of words, capturing their meanings based on context. And the doc2vec, it's similar to word2vec but for entire documents, enabling document similarity analysis. So, in this code example, first we import the necessary components from Gensim. Next, we define example documents as a list of lists, where each inner list contains words from a document. Then we create the dictionary which maps each unique word to an ID. Next, we create the corpus. The corpus is a list of bag of words representations of the documents. Each document is represented as a list of tuples, where each tuple contains a word ID and its frequency in the document. Then we train the LDA model with the corpus and specify the number of topics we want to discover. This example shows how Gensim can be used to uncover topics within a small set of documents, demonstrating its power and flexibility for larger datasets. Each of these libraries brings something unique to the table, whether it's the advanced text processing capabilities of SpaCy, the comprehensive tools of NLTK, or the specialized topic modeling of Gensim. By understanding and utilizing these tools, you can significantly enhance your NLP projects. Let us now look into the embeddings. The BERT, bidirectional encoder representations from transformers, provides context-aware word embeddings. Unlike traditional embeddings that represent each word with a fixed vector, BERT considers the context in which a word appears. This means that the same word can have different embeddings depending on its usage in a sentence. The BERT is excellent for capturing the meaning of words in context. For instance, in the sentences, "I went to the bank to deposit money," and "the river bank was overflowing," BERT understands that "bank" has different meanings and provides different embeddings for each instance. This capability makes BERT incredibly powerful for various NLP tasks such as sentiment analysis, named entity recognition, and question answering. The sentence transformers extend BERT to create embeddings for entire sentences, capturing the meaning of the whole sentence rather than just individual words. These embeddings are useful for tasks like sentence similarity and clustering. For example, they can determine that "how are you" and "what's up" have similar meanings. With this foundation, you'll be well prepared to dive into BERTopic and leverage its full potential. In today's session, we focused on setting up the environment for BERTopic modeling and had basic understanding of the necessary libraries such as NLTK, NumPy, Pandas, SpaCy, and others. In next lecture we will be focusing on understanding the BERTopic in detail. Thank you for joining us for this lecture. We hope you found the content informative and helpful. If you have enjoyed this video, please give it a thumbs up, share it with your friends, and don't forget to subscribe to our channel for more educational videos. Your support helps us create more valuable content for you. See you in the next video. Thank you for watching.